Welcome back my dear students, friends. So, this is the 22nd lecture of the series of lectures for the project management, which is a 20-hour course, and the total number of lectures is 14 number. So, I keep repeating it in order to make students understand where we are, how things are progressing. So, we in the 21st class we stopped at the point where how you calculate the forward pass method for the very simple diagram. So, for the first time in this whole series of lectures, I will again urge the student first to understand the forward pass method, the concept of how you utilize the early start and use the concept of early finish, and how you use the concept of late start and late finish. But remembering that in the forward pass method, you will only start the job once all the preceding ones which are in such a way that they are dependent on the jobs we are considering finish, until unless, say for example, in the last example that if 4 cannot start in one example at the end of the 17th day, and in another case it cannot start at the end of the 3rd day. So, obviously, we will consider 17, because 17 would mean that all the preceding jobs or activities of or the task corresponding to the 4th job have finished. So, now let us basically use the same concept from the backward pass method, but remembering that the concept was basically for the early start or the late start for the forward pass method. In the backward pass method, it will be the finishing concept which will be utilized. So, let us consider in the slide 267 the PERT, which is the backward pass method, and the activities in the initial forward pass method were from the left to the right. So, 1, 2, 2, 3, 3, 4 and so on and so forth were basically put on the slide such that you do your calculations accordingly. But now, in the backward pass method, you will basically note down the jobs from the right to the left. So, if you see the leftmost column which you have of the series of the activities, it is not 1, 2, 2, 3 and so on and so forth, but basically the activities are from 5, 6 till the last one, which is 1, 2, and correspondingly to the right of the activities you have again written down the duration. So, for 5, 6 the duration is 10 days, similarly for the last one, which is activity 1, 2, it is 14 days. Now, let us proceed how we have basically done the problem for the backward pass method, considering the duration of the total job is 35, which we calculated from the forward pass method. So, what was that? That was 35. So, let us write down 35 here, which is the late finish, for the activity 5, 6. So, based on that we will proceed. So, the late finish for 5, 6 is 35 number of days. Now, let us ask the question, what is the number of days required for the 5, 6 job? It is 10 days. So, the late start which you can do for activity 5, 6 would basically be 35 minus 10, which is the duration, which is x or d suffix a, d suffix b, whatever you utilize, and it gives you the value of 25. So, note it down, it will become much sense then as you proceed by the backward pass method. Now, for the activity 4, 5, you will ask us ourselves the question that 4 and 5 can end only once the job 5, 6 had started. So, they take basically, let us put it another way, 5, 6 cannot start unless 4 and 5 ends. So, obviously, the ending and the starting of 4, 5 and 5, 6 should be timed accordingly. So, if you consider the late finish for 4, 5 can be only 25, which is coming from here, and if I want to find out the late start for 4, 5th activity, it would be 25 minus 3, which is 3 is the number of days, which is 22. So, note it down 22 and do the calculation. Now, let us come to the activity 3, 5. So, 3, 5 again if you consider 5 is coming from here, which is basically the first bullet point here, where I am basically marking my pointer. So, activity 3 to 5 would only end based on the fact that after that 5 and 6 can start. So, let me understand that what is the late finish for this activity 3-5 would be 25, which is coming from here, and if I want to find out the late start, it will be 25 minus the number of days which is required for activity 3-5. So, it is 25 minus 4, which is 21. Let us come to activity 2-3. So, 2-3 can basically only end based on the fact that activity 3 and 5 basically would have started after that only. So, the late start is 21, bring this 21 here, which is late finish, and then if I want to find out the late start for activity 2-3, it will be 25 minus the number of days which is being consumed for doing the activity 2 and 3, which is 7. 21 minus 7 is 14. Then let us come to 2 and 4. So, in 2 and 4, if we consider, let us go where 4 has just started. So, it was late start was 22, 22 comes here, 22 minus 3 is 19, and I find out the late start of activity 2-4. When I come to 1-4, so 1-4 I find out is basically coming from the fact when 4 and 5 would start. So, that was basically 22, which is the late start for activity 5. So, this 22 comes here, 22 minus 3, which is the number of days for the duration for doing job activity 1-4 was 3. So, 22 minus 3 is 19, and the last thing which I do is basically for activity 1 and 2. So, 1 and 2 for that I now go, which is the late finish. Now, here is what I want to point out. If you see activity 2, so this would end, and after that only activity 2-3 and 2-4 can start. So, let me note down what are the points, let me highlight it for our better understanding. So, one is this one is this one. So, there are two jobs 14 and 19. Now, if it is 14 and 19, I want to ask myself that 1 and 2 what would be the late finish. So, if I am considering the late finish for 1 and 2, considering that 2 and 3 and 2 and 4 can start, you will see automatically the late finish, if I am going from the backward pass method, would be 14, such that the late start would exactly match the day 0 based on the fact when the actual activity or the set of activities for the whole project should start. So, as you are doing the backward pass method, remember your main important fact is the late finish, and as you are doing the forward method, you are trying to basically concentrate on the concept that as you proceed, your early start, early finish, late start, late finish would be considered in the same sequence of ways, such that logically it means that a job can only start after the fact that all its predecessors have finished. So, considering if there are 3 predecessors, I will only consider the job after all of them has finished. So, what is important to know is that in the PERT forward method, you will do the calculations and find out the jobs where I am pointing my finger. In the last slide 266 slide you saw that. Similarly, when I come to the backward pass method, again I have the set of jobs. So, now let me point it out for the, so this set of values would be needed for me, these one. Similarly, they would be needed for the forward pass method also. So, once I have the forward pass method values and the late and the backward pass method values, I need to find out what is the total slack, what is the free slack. So, now if you remember, I had mentioned what is the concept of total slack and free slack. So, let me go back to the slide where we had considered that. So, these before I go, these were the forward method and these values were needed for me. So, these values are needed, and if I go to the forward method and so the total slack or the free slack was basically this. So, this is in slide 248. So, I did consider that, considering that people have picked up. So, these are the formulas which I am going to use. So, total slack is late start minus early start, and total slack is also late finish minus early finish, and the free slack would be basically given accordingly. So, let me again jump back to slide number 267. So, these were the values. Based on that, once I do that, I have the total slacks for all the activities. So, I use the formulas as the total slacks is given. I would not do it, I will strongly urge the students to do it. So, what is best is that write it down using the formulas of the forward pass, backward pass, and use the concept of total slacks. Once you find out the total slack values, the values are given here. Activity 1, 2, total slack is 0. So, if you remember, free slack would be less than equal to total slack, which means total slack is 0, free slack is 0. Activity 1, 4, total slack is 19. So, free slack can be there positive or less than, if it is less than equal to 19, it can be any value. What is the value? I am going to come to that. 2, 4 has a total slack 5, 2, 3 has a total slack of 0, 3, 5 has a total slack of 0, 4, 5 has a total slack of 5, and activity 5, 6 has a total slack of 0. Now, again I am mentioning that the total slacks and the free slacks are calculated as denoted just few minutes back in the slide and noted down. So, now I want to stress the fact to the students, pay attention to the values of total slack being 0. So, let me highlight it. So, what does it mean? It means that whether you are going from the late start, late finish, or consider the early start, early finish, whatever concept, the amount of leeway for these 4 corresponding activities 1, 2, 2, 3, 3, 5 and 5, 6 is 0. That means, you do not have any leeway. If there is no leeway, it means they are on the critical path. So, if I draw it using the diagram which is there, and now the critical path is being denoted by the red lines. So, the critical path is basically 1 to 2, 2 to 7, 3 to 5 and 5 to 10. If I consider the total number of days, it will be 14 plus 7 21, 21 plus 4 is 25, 25 plus 10 is 35. So, the total number of days required critical is 35. Now, if I consider the overall amount of leeway which I have, consider this. If I am going to 4, so 4 can only start, 4 to 5 can only start after 1 4 and 2 4 is finished. So, now consider 1 4 is this 3 number of days is finished, but to reach 4 through the other route, which is basically 1 2 2 to 4, you need 14 plus 3 number of days, which is 17. Now, 17 means basically if 1 and 4 is finished 3 days, it will have a huge amount of cushion. What is the cushion? That 17 minus 3, that total number of days would be there, such a cushion such that in case is there is a delay, you can delay it by a total quantum of 14 days, that means 1 and 4. Similarly, if I go to 5, so 5 can basically only start 14 plus 7, which is 21, 21 plus basically 4 is 25. But if I consider 5 or the other work which has to be finished, it can be 14 plus 3 17, 17 plus 3 is 20. So, here it is 20, here is 25, that means you have a so called cushion of 5 days which can be utilized. How you utilize that? That will depend on what are the constraints which you are facing. So, now what I explained, I am trying to basically explain in more detail in this 270th slide. The free slack for any activity is defined as the cushion which is available without affecting the early start of any other activity. So, free slack you want to find out considering the concept of total slack would be earliest of ESJ, which is the early start of the jth job minus early finish of the ith job. So, I am going in the sequence of I is before j. So, I am basically going from the left to the right, I would come, j would come and corresponding whatever variables which you take. Here j is the set of all activities jobs which are immediately successor to the activity of job activity task I. So, I would be predecessor of j, j is the successor, all sets of jobs which are there. So, if I consider activity 1, 2 which is a duration on 14. So, I will basically consider the free slack which is 14, this first term is 14 on the right hand side is basically the early start of all the sets of jobs which follow 1 and 2. So, that is 14, the early finish for that particular job is basically 14. So, hence I have the free slack for 1, 2 as 0. Similarly, if I go to basically activity 1, 4, the early start for all the set of jobs which are after 1 and 4 is 17 minus 3 which is the early finish of the ith job, corresponding to that the free slack is 14. Similarly, I find the free slack of 2, 4, 0 which is 0, 2, 3 is 0, 3, 5 is 0, 4, 5 is 5 and activity 5, 6 is 0. So, total slacks are calculated, free slacks are calculated, we have found all the critical path also. So, now what is important to note, let me just let me go back to the 270th slide. Free slacks are given, let me go to the total slacks. So, let us consider here total slack for 1, 2 activity was 0 here, see here the free slack is 0. If I consider 1, 4 free slack is 14 while the total slacks were 19, which means there is a cushion of 5 days which we can utilize. So, depending on the total slack and the free slack we can find out the cushions and do our calculations accordingly. So, where there you can shift a job in block or in parts if parts are allowed such that it does not affect your total critical path and the total duration. Crashing is not being considered now. So, now based on the central limit theorem, the project duration may be assumed to follow a normal distribution. Now, you may be guessing that till now we have been considering the beta distribution, now we are basically telling it is the normal distribution. What we are considering that if we keep repeating and doing the simulation concept, we will see that the distribution which we will be utilizing in order to find out the overall distribution of the simulation concept for the time duration for any set of activities for the job would basically be normal distribution using the central limit theorem. This is very important concept in statistics. So, this can be used to answer two important questions or several set of important questions. One is what is the probability that the project will finish within a given deadline based on whatever the deadline is given. Why it is necessary? Because in many of the contracts, many of the projects, many of the work being done, set of activities is done, there would be a deadline such that the contractor would be penalized if the deadline is exceeded, but on the other hand the contractor would get a benefit if the deadline is not exceeded, in the sense the work is finished before the deadline. So, obviously, you have to have a cost benefit analysis based on whether the deadline is exceeded or not exceeded. Now, we will also try to answer that what deadline should be set if the probability of the meeting should be at least x percentage. So, if I want to find out that within the deadline or within, say for example, 15 days of the start of the work, what is the probability that what portion of the job is finished, or say for example, we can also try to answer that if there is a probabilistic framework of time duration and the resource constraints are there, or if time durations are in increasing or decreasing for different type of activities. So, we may try to find out that within the deadline of, consider the contract had been signed for 90 days. So, within that 90 days what percentage of the job has been finished. So, if say for example, 90% of the jobs have been finished, we will only concentrate on the less 10. Based on the fact, we will try to find out that those 10 would consume what extra amount of resources and what is the corresponding cost. Or else we can also consider that if those 10% have to be crashed, then what is the overall cost I have to bear in order to meet the deadline. So, the probability distribution that the project has, if it is T, then obviously using the simple concept of normal distribution, we can find out like this. So, if the probability is, say for example, T is less than equal to D, where D is the deadline, then you can basically find out T minus the expected value of T, which is the average time, divided by the standard deviation. So, this is standard deviation for the time duration. So, I want to find out d minus E by t divided by sigma t. So, this whole value would be, say for example, probability is alpha. So, this alpha value if it is given as 90%, we will try to find out that using standard normal deviator tables, that what percentage or what is the time taken or the deadline such that we are able to complete either 90%, or if you are going the other way around, like not fix the percentage of finish, but we want to finish fix the time duration, then we can find out what is the percentage of the value of alpha, based on which we can take action accordingly. Et is the expected value of the total project duration, Vt which is sigma t here is the square root square of sigma, and variance is the variance of the total project duration, and this capital value of this is the normal distribution, which we consider with a mean value of 0 and standard deviation of 1. So, if you want to fix the deadline z that can be obtained with probability x, then we need to find out this. So, whatever formula I just wrote in the 272nd slide is exactly this. So, I need to find out t less than equal to d is equal to alpha. So, if I know alpha, then I can find out t minus expected value of and this variance of t, probability of this, d minus E of t, variance of t, and do your calculations accordingly. In case if it is not there, so alpha is fixed, then you find it out, or say for example, if alpha is not fixed now, so what I will do is that I find out the probabilities, use the same formula, put it to some alpha. So, alpha is not fixed, but d is fixed. Based on that, I can find out alpha and do my calculations accordingly. And use simulations, central limit theorem, standard normal tables to do the calculations. So, again I will come back to the Gantt charts. So, consider you are doing a construction job. So, the construction jobs descriptions are clear for the construction, concrete forms, reinforcement, pour concrete, clear grade, and sewer lines have to be fixed for building a civil civil engineering building. And the durations of the days are mapped along the horizontal line from left to right, and the bars which you see, the solid horizontal bars, these are the durations which are there for the construction. So, what is again I want to highlight, even though we may have gone through that, is that what is the relationship between these activities which are there on the first column, like clear for construction, concrete forms, reinforcement, pour concrete. What is the relationship between the activities considering time duration is very important. So, if I consider the time duration, what is important is that whether I will ask myself whether there is some delay between the end of activity A, consider this is A, B, C, D, E, F. So, if there is a delay between A and B, or else there is a delay between the start of B and start of C. So, this is what we are trying to bring to the picture, that the Gantt chart would also consider the concept of end to end, end to start, start to end, and start to start. So, this is basically end to start. So, end to start would be here. This is basically, if I consider this one and the second one B and C, it will be end start to start. So, start to start would be here. So, correspondingly the Gantt chart has been shown here, where pouring concrete, which is D activity, would only start after, say for example, reinforcement and concrete forms are done. So, relationship between B and D and C and D would be end to start. Similarly, if I go to clear grade, it may so happen that clear grade would have a relationship such that it would be an end to start also from point of A and E, or it can be basically start to start between corresponding to job activities C and E. Similarly, for the F, which is sewer lines, you have the the activity is marked in the bold horizontal line, and it may also mean that the end of E and end of F have to be same. So, in that case it will be end to end concept would be utilized. So, similarly I can consider that I am trying to basically move the jobs. So, if you consider the 274th slide and the 275th slide which is there in front of you, you can see many of the jobs can be shifted such that the concept of slack which we considered in details using the forward pass and the backward pass method is making sense once we consider the Gantt chart. So, initially the Gantt chart we considered was to only depict what is the concept of Gantt chart. Later on here in the 274th and the 275th slide, I am trying to portray Gantt chart such that it will also be able to portray the concept of end to end, start to start, start to end, and all this concept in a very nice manner. But using Gantt chart in tandem with the precedence diagram gives a much better picture. So, that is what is the main focus of the discussion for the last 2 minutes. In the Gantt chart, we must know the dependence between jobs and activities and tasks. So, those dependence structure considering what concept we are using, whether it is end to start to start or start to end, should be considered in a very clear cut manner. We must know the respective job, activities, task, early start and a late start time. So, these are important considering which concept you are following. So, if it is EE which is end to end or start to start, you will consider those accordingly and also do the calculations based on the fact that what precedence concept are you using. So, based on that you will do the calculation. So, for the problem which we solved for the forward pass and the backward pass method, we simply use the end to start concept, which is true for the critical path and the PERT method. So, we should remember that there are external factors which may affect the start and end of the jobs based on which we can do the calculation. So, these charts which we just completed for the Gantt one gives us an overall picture of the number of days which will be required to finish the project. So, for the PERT and CPM we must find the amount of slack, the total slack and the free slack which is available for each activity job. For the critical path it is slacks is not available, which means that you do not have any leeway to change the start and the finish of the jobs in the critical path, but obviously you can crash such that the overall cost would come into the picture. For non-critical path, slacks may be available for an or a set of activity. This means that if due to unavoidable circumstances we face some problems, we can absorb the delay by utilizing the slacks from these non-critical activities in some way if possible in the critical concept, but it will definitely increase the cost of the project. So, crashing would then be required. So, this problem which you have already done is if you see the critical path. So, here you have 14, 7, 4 and 10 for the critical path. So, this 3 means that you are trying to basically consider it in such a way that there is a cushion. So, any add-ons here in B or trying to delay may not affect the critical path, but if it does affect, then obviously crashing and such delays and cost overruns would be there. So, with this I will end this lecture and then consider the concept of critical path and critical method, CPM method and PERT method with more problems, and then slowly go into the crashing of the jobs and explain this concept in detail. Thank you very much and have a nice day.